Welcome to another Java programming tutorial. Today, we're diving deep into an intriguing and historically significant encryption technique called the Vernam Cipher, also known as the one-time pad. This method is fascinating because it offers perfect secrecy when implemented correctly and is a great exercise in understanding basic concepts of cryptography. First, let's discuss a little about the history and concept of the Vernam Cipher. Developed by Gilbert Vernam in 1917, the Vernam Cipher is a symmetric key cipher where the plaintext is combined with a random key, or pad, that is as long as the plaintext itself. The key must be truly random, used only once, and kept secret between the communicating parties. To begin implementing the Vernam Cipher, let's start with the basics. The primary operations we'll be using are bitwise XOR, exclusive, or operations which can be performed on binary representations of characters. Our plan is simple. We'll create a method to encrypt and decrypt messages using this cipher. Let's set up our Java project first. You can use any IDE like IntelliJ, Eclipse, or simply a text editor along with the command line. Make sure you have Java installed. The Java version 8 or greater is preferred for this tutorial. Now, let's create a new Java class named Vernam Cipher. Inside this class, we will define our methods for encryption and decryption. Here's how we do that. Next, we need to create a method for encrypting the plaintext. The encryption function will take our plaintext and the key as parameters. For our example, we will populate the key with random characters. Let's create our code for encryption. In this method, we loop through each character of the plaintext and the key. For each character in the plaintext, we take its corresponding character in the key, perform a bitwise XOR operation, and append the result to our encrypted message. Now we need a method to generate a random key. Remember, the key should be as long as the plaintext and must be completely random. Here's how we can generate a random key. This method generates a random key by appending random characters to a string builder. Note that we're generating characters based on their ASCII values ranging from 0 to 255. Once we have the encryption method and key generation in place, let's implement the decryption method. The decryption process is essentially the same as the encryption process because of the properties of the XOR operation. As you can see, the decryption method reuses our encryption method since applying XOR again with the same key will reveal the original plaintext. This is key to how the Vernam Cipher functions. Now, let's put everything together in the main method so we can see this cipher in action. Here's how we can do that. In the main method, we create an instance of our Vernam Cipher class, generate a key for the plaintext, encrypt the plaintext, and then decrypt it. We also print the plaintext, the random key, the encrypted text, and the decrypted text to confirm it matches the original. Now, let's run our code to see how the Vernam Cipher works in practice. As we can see from the output, the original plaintext is successfully encrypted and then decrypted back to its original form, demonstrating the effectiveness of the Vernam Cipher. Before we wrap up, a quick note. Although the Vernam Cipher provides theoretical perfect secrecy, it's crucial that the key is truly random and used only once. If a key is reused or predictable, the security of the encrypted message can be compromised. To summarize, we explored the foundation of the Vernam Cipher, how to implement it in Java using simple methods for encryption and decryption, and highlighted the importance of randomness in key generation. Understanding and employing techniques like these is essential for secure communications. Thank you for joining me in this tutorial on the Vernam Cipher. If you found this helpful, please like and subscribe for more Java programming content. Don't hesitate to leave your comments or questions down below. Until next time, happy coding!